Today we will study Unit 2, Atoms, Elements, and Compounds. In this, inshallah, we will cover metallic bonding. This is from the O-Level GCE 5070 syllabus, and it is almost exactly the same in the IGCSE 0620 syllabus as well. If you compare both syllabuses, they are almost the same. So first we will see what metallic bonding is, right? If you look at metals, metals are those which lose 1, 2, or 3 electrons. And when they lose electrons, we've already studied that they gain a positive charge, right? For example, here we have drawn a metal ion and then the electrons that it has lost. Metallic electron, metallic electron, metallic electron. In this way, we can draw 3 to 4 rows of metal ions and electrons. Whenever you are asked to draw metallic bonding, you have to draw it like this. Now look here, the plus signs represent metal ions. It can be any metal, sodium, iron, copper, aluminum. And these E symbols in black color represent delocalized electrons or bonding electrons. These are the electrons that the metal has lost. Now see this, this green metal ion, which electrons is it attracting? All the surrounding electrons, shown here in purple, it is attracting all of them. Similarly, this yellow electron is attracting all the green metal ions. So, in short, just like in ionic bonding, a sodium ion attracted all nearby chloride ions. In the same way here, metal ions attract electrons and electrons attract metal ions, right? Now, one more important point. Metal ions remain fixed, while the delocalized particles that move are the electrons. That is why we call it a sea of electrons, because many electrons are moving freely. You can also call it a cloud of electrons or a sea of electrons. So in short, the definition of metallic bond is the electrostatic force of attraction between metal ions and delocalized electrons. The attraction between these two is called a metallic bond. Or we can say the force of attraction between metal ions and the sea of electrons or cloud of electrons. When you draw metallic bonding, there are some key points. You must label metal ions and electrons clearly. Also, you should draw at least 4 columns and 3 rows so that you clearly show the attraction between ions and electrons. Also, draw them alternately. Positive ion, then electron, then positive ion, then electron. In this way, you show metallic bonding. Now remember, all metals are solid at room temperature, except mercury, which is liquid at room temperature. Also, the greater the charge on the metal ion, the stronger the electrostatic force of attraction. More charge means stronger attraction. For example, the melting point of magnesium is greater than that of sodium. Why? Because magnesium has a higher charge. Higher charge means stronger attraction between magnesium ions and delocalized electrons compared to sodium. That is why magnesium has a higher melting point. Also, metals like iron and magnesium generally have high melting points. If the reason is asked, you should write that the electrostatic force of attraction between metal ions and delocalized electrons is strong. So we studied 2 things. Metals have high melting points because of strong electrostatic attraction. Second, higher charge means stronger attraction. Next, metals are good conductors of electricity. Why? Because they have delocalized electrons or free mobile electrons. You can also call them bonding electrons because they form metallic bonds. Next, metals are malleable and ductile. Malleable means they can be made into thin sheets. Ductile means like they can be drawn into wires. Now let's move ahead. Question 12, Paper 11, June 2020 GCE. The question is, element X has a lattice of positive ions and a sea of electrons. If you look below, a diagram of metallic bonding is shown because you can see positive charges, then electrons, and then positive charges again. Lattice means a regular repeating structure. Positive ion, electron, positive ion, electron. The question is, which property will X have? Pause the video and try to solve the question. Now look at option A. It conducts electricity by movement of ions and electrons. But here it says movement of ions. Ions remain fixed, only electrons move. So A is incorrect. Option B, it has a high melting point. We already studied that metals have high melting points. So B is correct. Option C, it is decomposed by electric current. This is false because metals are used to make wires, like copper. They do not decompose. Option D, it is not malleable, but we just studied that metals are malleable. They can be converted into thin sheets. So D is also incorrect. Now moving ahead, question 2a, paper 41, June 2020 GCE. The question is, magnesium is a metal. Name and describe the bonding in magnesium. Pause the video and try to solve this. We know magnesium is a metal, so the bonding will be metallic bonding. Next, we describe it. Metallic bonding is a strong electrostatic force of attraction between magnesium ions and delocalize electrons. If you write strong electrostatic force of attraction and delocalized electrons, you will get 2 marks. 1 more mark is for writing that it has giant metallic lattice. Now moving ahead, question 5CI, paper 21, May, June GCE. The question is, silane has molecular formula SiH4. Draw the dot and cross diagram. For it to show, you need to show only outer shell electrons of silicon. Pause the video and try to solve it. Now see, silicon belongs to group 4, 10 so it has 4 valence electrons. It needs 4 more to complete its octet. So silicon will share 4 electrons. Hydrogen belongs to group 1. It needs only 1 more electron to complete its duplet. So each hydrogen shares 1 electron. We represent silicon electrons with dots and hydrogen electrons with crosses. So silicon shares 1 electron with each hydrogen. This way it forms bonds with 4 hydrogens. Now, part 2, the question is, silane has molecular formula SiH4. Using structure and bonding suggest why silane has a low boiling point. Okay, this is a 2-mark question. Pause the video and try to solve it. Now, what are the key points here? We have to use structure and bonding. What do we mean by structure? Structure can be giant metallic lattice, giant ionic lattice, simple molecular structure, macromolecular structure. If it is a giant metallic lattice, the bonding will be metallic bonds. If it is a giant ionic lattice, the bonding will be ionic bonds. If it's a simple molecular structure, there will be intermolecular forces. If it's a macromolecular structure, there will be covalent bonds, right? Here, what kind of bonding are we referring to? We mean the bonding responsible for the physical state, solid, liquid, or gas. In simple molecules, intermolecular forces are responsible. If we draw the dot and cross structure of silane, this is what we get. So overall, what type of structure is this? It is a simple molecular structure. Therefore, the bonding present is intermolecular forces. So we can write silane is a simple molecular structure. It has weak intermolecular forces between its molecules. Because these forces are weak, only a small amount of energy is required to break them. Hence, silane has a low boiling point. Now moving to question 2a, paper 2, October-November 2017, GCE. The question is sodium chloride NaCl and magnesium chloride MgCl2 are both ionic compounds. Describe the arrangement of ions and the type of attractive forces between the ions in magnesium chloride, solid. Pause the video and try to solve it. For the arrangement, magnesium chloride has an ionic lattice. A lattice means a regular repeating arrangement. Remember when we studied NaCl, we drew a structure showing a repeating unit. These units repeat to form a giant lattice structure. So the arrangement is an ionic lattice, same for all ionic compounds. For the attractive forces, the forces between the ions are electrostatic forces of attraction between oppositely charged ions. Now question 2b, same paper. Explain why solid magnesium chloride does not conduct electricity, but aqueous magnesium chloride does. Pause the video and try to solve it. For electrical conduction, we need charge carriers. In solid magnesium chloride, the structure is like NaCl. The ions are in fixed positions and cannot move. Since the ions cannot move, they cannot carry charge, so solid MgCl2 does not conduct electricity. In aqueous solution, however, the ions are free to move. Just like in aqueous NaCl, the ions, magnesium ions and chloride ions can move freely. Because these ions can move, they can carry charge, so the solution conducts electricity. This applies to all ionic compounds. In solid form, ions are fixed, no conduction. In aqueous or molten form, ions are free, conduction occurs. Now our Unit 2 is complete. Today we discussed metallic bonding, solved some questions, and covered key concepts from the chapter.
Like, share, and subscribe our channel, SKW. We will try our best to give simple and effective educational information via the use of the best animation.